So let's say you're writing some code. That's a pretty reasonable thing to want to do. I find myself doing it once in a while. Let's say maybe you have something like if player.hp is greater than 0, checking to see if the player is alive or something of that nature, if they have a positive HP value. And maybe you want to combine that with another condition, for example, if player.coins is greater than 100. And this is your condition. This is your if statement. If these conditions are true, you might do something. Player.lives plus plus. That's 3 pluses. Player.lives plus plus. So when you run this code, if the player's HP is less than or equal to 0, and I'm going to increase the font size further. If the player's HP is less than or equal to 0, is the computer actually going to evaluate this part of the if statement? The answer is no. And this isn't really a GameMaker thing. This is actually something that's pretty common in computer languages. If the player's HP is less than or equal to 0, the computer will not actually bother to evaluate this part of the if statement. Hello all you crazy people out there, my name is Michael, I like wizards, dragons, and making games, and let's talk about lazy evaluation. So despite what the name suggests, lazy evaluation is not how I decide what to do with my Saturday afternoons. Instead it refers to the way many computer languages will evaluate conditions in either if statements or elsewhere in the code. These two statements here are joined together with an and, with a double ampersand, and that means that in order for this condition to be true, both expressions in this condition have to be true, and if one of them is false, then the whole thing is going to be false. So if player.hp is equal to 0, then this first part of the condition will fail. It will evaluate false, and therefore it doesn't matter what this half of the condition will evaluate as. This condition as a whole will never be true. This line of code inside this if statement block will never run. Likewise, if you were to use logical OR to join these two statements, then either of these conditions being true will make the whole statement evaluate true, and therefore if player.hp is greater than 0, then it doesn't matter what the value of this part of the statement is. It doesn't matter what this part of the expression is. The whole condition will be true, and this block of code will run. In either of those situations, the computer will not bother evaluating the second half of the condition if it doesn't have to. It's a small detail about how programming languages like GML and a lot of other programming languages work, but it is something that could potentially be useful, both just to make your code cleaner, if you understand the order in which expressions will be evaluated, and even as an optimization trick, since optimization is all about making the computer do less work than it has to, and if part of a condition is not going to be evaluated because it won't affect the outcome, that is de facto the computer doing less work than it otherwise might have to, and you can use that in clever ways to optimize your game. So instead of just taking my word for it, because I don't really want this video to be about 60 seconds long, let's do some examples. There's nothing actually in this game, in this project here, called player. This doesn't exist, I just started typing. You can see there is only this script and one empty room in this game. I'm going to get rid of that. Instead, I'm going to define two functions, and the first one is going to be function, let's call it first function, and it's going to show debug, did I spell that right? I did not spell that right. Message, first function, and it's going to return true. Okay, the second one is going to be similar, function, second function, show debug message, second function, and it's going to return false. Okay, we got a couple functions there. I'm going to start typing above these two functions and move them down a little bit. So if I were to say if first function and second function, we're going to do something else. Let's just, this is going to be the true condition, so show debug message. Condition is true, else condition is false. And this is going to pop out a couple lines in the console down here. Ooh, okay, there's still stuff in the console from when I was doing the truth value video recently. Okay, I am going to go and make the font size in the console bigger real quick. Hang on. God, where is that even located? Compiling? That's not it. Output windows. Let's make the font size like 16 or so. Is that the right one? That was not the right one. That was the source control window. I am not paying attention. So let's run this, and we're gonna see what happens. So we've got a couple messages in the console down here. We've got first function, we've got second function, and we've got condition is false. You can see how this works. First, the computer evaluates first function, and that prints out this message, and it returns true. And then it moves on to second function. Second function prints out its little message. Let's make this code window bigger. Second function prints out its message, returns false. True and false. Evaluates false. So the condition is false message shows up down there. So if you want to see that the computer will skip the second condition, if it can get away with it, if the first part of this condition is already false, we can switch the order of these around, and we can let's see, we can look at what showed up in the console. So instead of 3 lines, instead of saying second function, first function, and then condition is false, we have instead only seen the second function message. The game never enters this function. The computer never enters this function, and it doesn't print out its message. It doesn't return true because, as I said at the beginning of the video, it doesn't have to. And false and, well, anything is false, so it's going to go in here and print out condition is false. Okay. We should be pretty convinced that this is how GameMaker is going to evaluate conditions now. Again, if you wanted to reverse the order of these, reverse the operation rather, instead of anding them together, you can OR them together so that only one of these has to be true in order for this statement to evaluate true. So if we say second function or first function, we will be back to seeing 3 lines in the console. Second function prints out first. That is second function prints out first. Sounds awful. It returns false. So this part of the condition is false. But at this point, since we're using the OR operator, if the result of this function is true, then the condition as a whole will still be true. So we go and evaluate it in turn. We go into first function. It prints out its little message on the second line. It returns true, false, or true. Evaluates true. So we go into this block of code. And as I said a minute ago, if you were to reverse these, first function would evaluate true, and it doesn't matter what second function evaluates as. True and anything is going to be true. So we're just going to see the first function message printing out in the console, and then it's going to go immediately into the block of code. Okay. If you were to do this with any other with any other logical operation, so that's equals, not equals, or the often forgotten exclusive OR. This would not be the case because equals, not equals, and exclusive OR are all the result of the condition depends on both operands, both the left-hand side operand and the right-hand side operand. You could diagram this in a truth table if you want to see how it works. Also, for the record, exclusive OR has the same output as not equals when you're dealing with simple true and false, which is kind of one of the reasons why you don't see it very often. I guess if I were to run the game, you would see that it doesn't matter which order these two operands are, these two statements are, it's going to return the same thing. It's going to rather evaluate both of them both times. So this time, first function, second function, condition is true, and this is just going to say second function, first function, condition is true. Okay? You're all smart. You see where this is going. So let me delete all this. There's a couple places you could take advantage of. In the very old days of GameMaker, in GameMaker 8 and previous versions, this was not a thing. Lazy evaluation was not a thing, so it didn't matter if the outcome of a condition was known. After simply the first part of the expression was evaluated, it would evaluate the second one anyway. This was first added to GML in GameMaker Studio 1 at some point. It was actually optional. You could turn it on or off in the game settings. And I believe GameMaker Studio 1 called it short-circuiting evaluations instead of lazy evaluation, which seems to be the more common term for it. And now that we're in the days of GameMaker Studio 2, it's just the default behavior. There is no way to turn it off because there's really no reason to evaluate both parts of the condition if the first one determines the outcome. So, optimization, which I know is the exciting part. So some functions, as you probably know, are pretty fast to evaluate. If you're just performing a check, if you're just performing a check, like if value is not equal to undefined, this is pretty fast. It doesn't take the computer long to evaluate these. Some other functions are pretty fast. If you have something like instance exists instead of not equals undefined, this is pretty fast. All things considered, this is just looking up to see if an instance exists. It's just a lookup. It's not performing any complex operations. Some of the GPU function getters are pretty fast. So if you were to say GPU get like alpha test ref, no, that's not a true false. Alpha test enabled is a true false. This is pretty fast. This is just looking up the state of a setting in the game, whether or not you have alpha blending enabled. This is pretty fast. There are some other functions that are pretty slow, and those tend to be things like the collision functions, so place, meeting. This function checks for collision. It could be rather slow if you have a lot of things checking for collision in your game. There's a bunch of other collision functions. Instance, place, I think, is one. I don't use the collision functions very often. Same deal with this. If you have many instances in the game that you're checking collision against, this function could perform rather slowly. There's always things like collision circle, collision ellipse, collision line, collision rectangle. These are all collision functions. GameMaker's collision system is generally pretty good, but if you have a truly staggering number of collisions in your game, or if you're checking collisions with a large number of instances at the same time, then it could slow down all the same. Then there are some functions in GameMaker which just have the potential to have to do a lot of work. So things like dsgrid, find max, dsgrid, get max. Alright, there we go. dsgrid get max. If you're checking a large region in a dsgrid, this function could be pretty slow just because it has to check a lot of numbers. Get disk mean, disk sum. These are other dsgrid related functions that could have to do a lot of work. I'm just making stuff up off the top of my head here. I'm just spitballing. Let's say that if you had a puzzle game of sorts and you wanted to check the values on a grid to see if the player won the game or not. Maybe you would say dsgrid get disk sum grid. Maybe you're checking the middle of the grid, like 50, 50, if the grid is the size of 100, with a radius of 50. This would mean the computer has to do a fair amount of work to evaluate this function because there's a lot of area being checked. There's a lot of math being performed, and you also wanted to see if the player's coins is greater than 100. Let's say these are the two win conditions. And this is going to be rather abstract. This is going to be very computer sciencey and not a lot of like gameplay stuff going on. But for the sake of this script, just so that I can run the game without it exploding, let's say var grid dsgrid create. The size can be like 100, 100. Let's make it 200, 200, just to make it a little bit bigger so that we can actually, you know what? Go big or go home. Just so that we can hopefully see how much time could possibly be saved. And then, I don't know, dsgrid set region grid. I don't even need to populate this, really, because we're not going to be doing anything with the result. Let's go from index 0 to index 499, 499. And let's give it a value of, for example, 1. Okay, that's fine. Let's get the middle of the grid sum, which is going to be 250, 250, and it's going to be a radius of 250. Let's just pretend we want this to be greater than like 10 or something, which I think it will be if my understanding of math is correct. Show debug message, you win. Else, show debug message, you lose, with a frowny face. Okay, so I can run this code, and this code will actually do something. It will not actually do anything because player does not exist. So let's actually create the player. Player is going to equal just, we can make that a struct. And the player can have a variable coins, and we can make that like 100 or something. No semicolon and structs. So we're gonna lose because player's HP is not greater than 100, and we can see that it took some time. Actually, we can't see that it took some time because there is no timing mechanism. Anyway, we're gonna lose. This condition is going to evaluate false overall. dsgrid get sum. The sum of the center of the grid is going to be greater than 10. I can tell you that much. I don't know exactly what it's going to be. It's probably going to be something about 250 times pi, because pi r squared, but that's a little bit of geometry. We can time this with a favorite trick of mine involving the get timer function, and get timer returns the exact number of microseconds since the game started, and we can use get timer to get a timestamp of when code begins to run, and we can use get timer again at the end of that code to see how long it took, what the difference in time is, how much time has elapsed, and we can just show debug message code took this number of microseconds to run. Okay, we will see how long this takes. And this is about a millisecond. 1,214 microseconds is how long that took to run. Okay, that's not maybe something that you want to be doing in a step event. It's not horrendous, but doing it 60 times a second could kind of start to suck after a while. Now, lazy evaluation tells us that if we were to instead put the player.coins is greater than 100 condition at the front of this if statement, this is going to be false. And therefore, because these two values are being anded together, it doesn't matter what the result of this calculation is going to be. This condition as a whole is going to return false either way. And we will not actually have to run this big, heavy, expensive dsgrid get sum function. So let's run this again. And this should only take a couple microseconds to run. And you can see code took 27 microseconds to run, which is literally 50 times faster than the other version. Okay. I think I got this video out on the first take, which I will definitely be happy about if true. So I'm not saying that if you will always get a 50 times speed increase if you use lazy evaluation like this. Of course, it obviously depends rather heavily on the actual code that's actually running. It's not like all functions in GameMaker have a set amount of time that they will always take to execute. It's not like the second condition will always be 50 times slower than the force condition. Depending on what you're doing, if you're doing heavy math like this, it can definitely speed things up. It can definitely speed your game up. If you're doing collision checking especially, it can definitely speed things up. If you're doing something like pathfinding, if you were to do something like if player dot can move is true and mp grid, what are the mp grid functions? Mp grid path from one location to another. If you're doing something like AI navigation, obviously this condition is going to be much faster to evaluate than an mp grid function on any decently sized grid. Pathfinding is a rather expensive operation. It's not terrible. It's not something you should never do, but it is somewhat more expensive than most things that you will do in GameMaker. And you generally want to avoid doing it if you don't have to. For example, if the player can't actually move, or if an enemy can't actually move, there's no point evaluating a path in those situations. Now, I should mention, maybe I shouldn't say I should mention, but I would like to mention that if you happen to still be using an ancient version of GameMaker, you can still do this kind of. As I said, in GameMaker 8, both halves of the condition will be evaluated, even if they don't have to be. And if you would like that to not happen, you can rearrange this if statement a little bit. You could instead make that one if statement, and you could put this in another if statement. Let's get rid of some of these parentheses just so that this is easier to read. And you could make these separate if statements, and making them separate if statements will force the computer, regardless of whether or not it does lazy evaluations, to just skip this stuff in here if this first statement evaluates false. You can do it. It's a little messier than just putting them in the same if statement. But if you happen to be using GameMaker 8, because I know that for some reason, and I guess this is just a testament to how crummy the educational licenses for GameMaker have been since like GameMaker 8, a non-zero number of like schools and stuff, you still use GameMaker 8 and 8.1 to teach like introduction to computer science stuff. So if that's the situation you find yourself in and you want to use lazy evaluation, then you can sort of spoof it like this. All right, let's join these together once again with an and. There we go. Very nice. Do I want to put this code on GitHub? I might start to lean towards making just like single individual gists, single individual code files for exercises like this that aren't actually a real game. I'll probably do that. Look in the video description if you want to copy this code and mess around with it or whatever. If you want to play around with this get timer function and like do speed tests on your code to see how long it takes to execute. I did a video on that a very long time ago. It's one of the few older videos that I actually still like, is timing your code with the get timer function. Anyway, that's it. If you didn't know about this before, hopefully you do now, and hopefully it can make your game development adventure somewhat easier. I have a Patreon, so if you want to contribute towards these videos being made, there will be links to that in all the usual places. Otherwise, I try to post about 2 game dev, GameMaker videos a week. One tutorial like this, and one Let's Make a Tower Defense game. I normally try to make videos on the more obscure things you can do in GameMaker, the more obscure pieces of knowledge that don't get talked about very often. So if that's the kind of thing that you're into, definitely subscribe. I try to post these things on Wednesdays and Saturdays. Anyway, that's it. I hope you found that interesting, and I will see you all later. Special thanks to David Key, Edward Holt, Emily Koyo, Posho, and Zenith for supporting these videos. If you want your name in the credits or to hear yourself shouted out at the end, head on over to the Patreon page in the video description to join the fun.